All right, so in today's video, we're going to be going over Regents Review 4. So let's take a look here. We want to express this expression in simplest form. So what we're going to do is we're going to factor the top, and you can see I did that in blue, factored by grouping. Then we got x squared minus 9 times x plus 2, x squared minus 9 here is difference of two squares. So we have the square root of x plus the square root of 9 times the square root of x minus the square root of 9. And then we bring the x plus 2 down. As you can see in red, I factored out the x, leaving us with this trinomial here. Factors of -6 that add up to -1 are -3 and 2. Don't forget to bring down the x times x minus 3, x plus 2, cancel out what is the same top and bottom, and we're left with x plus 3. All right, next one, we are going to evaluate the expression. So anytime you see binomial squared, you want to rewrite it using FOIL. So we have the two binomials multiplied together, minus, and then we do the same thing here where we write it out in expanded form and then multiply. We're going to combine like terms. As you can see, I squared is equal to -1, so this becomes -9. This also becomes -9. Don't forget to distribute that negative. We combine like terms, and we get 3 as our answer choice. Okay, next one. So we can use our calculator for this, and we can put our function in the calculator. Okay, go to second graph, and it wants to know the average rate of change, which one was the fastest. So if we're taking a look from 1, which is 97, so I'll put that in another color, 97.26 minus 79.45 over over, that was the other one, 1 minus 10, we can see that is 97.26 minus 79.45 over 1 minus 10. Oh. All right, that's going to be negative 1.98. And as we go through, that is going to be the average rate of decay, which was the fastest. And then, all right, so moving on. So for the next one, we're going to be multiplying each expression in the equation by x times x plus 3 so that we can cancel out the denominators. So in our first part, we have the x's that cancel out. So I multiplied 2 times x plus 3. Minus here the x plus 3 cancels out, so I have 3x times x, which is 3x squared. Here the x plus 3 cancels out, so I'm left with x times x squared. Okay, and this is a quadratic. So we're going to so this is a quadratic. So we're going to set the one side equal to 0. Okay, by just moving these terms over to the right-hand side. I like to keep the x squares positive, so I moved everything over to the left. So then we get 0 equals 4x squared minus 2x minus 6. So I'm going to divide by the GCF. Everything is divisible by 2, so I'm going to divide that on both sides. Still have 0 on the left-hand side. We have 2x squared minus x minus 3. So I'm going to factor that out. 2 times negative 3 is negative 6. Factors of negative 6 that add up to negative 1 are negative 3 and 2. Factor by grouping, we have 2x minus 3 times x plus 1. Set those equal to 0. Before we can say that this is our answer, we want to check to make sure that none of these values for x make the denominator equal to 0. Negative 1 is good. 3 over 2 is good. So we have our answer choices of negative 1 and 3 over 2. All right, so here I did a little bit of guess and check to see if x plus, since x minus 1 is a factor of this expression, we're trying to look for the value of of k. Which actually, now that I think about it, let's take a look at this again. So if we look here, you can see that each of them have an x, so I factored out that x. So if we have x minus 1, if this is a factor, this negative 1 has to multiply by something that's going to give it a positive 2. So negative 1 times negative 2 is going to give a positive 2. So now I'm going to multiply to see what the value would be for k. So because, which I missed before, because it's this negative, I have to plug in a positive 3 so that this value would stay negative. If I put in a negative 3, that double negative would be positive. Okay, next one. Okay, inverse. So for inverse, we're going to change f of x to y. We're then going to flip the x and the y. So x equals y cubed minus 2. Now we're going to solve for y. So add 2 on both sides. We get x plus 2 is equal to y cubed. We're going to take the cubed root on each side. So since we are just finding the inverse and we're actually not solving, it's going to be choice 3. So when we take the cubed root, y is going to equal cubed root of x plus 2. All right. So this next one says the profit P of x for a company is given by this equation. To find the cost, we need to take that value subtracted from the revenue, which is R of x. So I highlighted subtracted from because if we're doing subtraction and it says subtracted from, we need to flip the order. So we're going to be doing R of x minus P of x. Don't forget to distribute that negative. And we should get a positive 0.5x squared, a negative 250x, and a positive 300. When we combine like terms, we get negative 2x squared minus 100x plus 300. Okay. So this one's giving us an equation for the half-life of iodine. When the equation is written in terms of E, we can use this function. So it's saying that they are the same, right? So if we want to solve for K, we don't want to have both K and D in our equation. And since they are the same, they're equivalent, if we say that D is equal to 1 on the one side, D is also going to equal 1 on the other side. This way we only are left with K. So now we're going to get rid of the 100 by dividing by 100 on both sides. That just eliminates it. So then we have 1/2 raised to the 1/8 is equal to e to the k. So since we have a variable in the exponent, we're going to log both sides. And since it's an e, we're going to use the natural log. Okay, so as you can see, if I put in my calculator, if I did 1/8 ln of 0.5, we're going to get roughly negative 0.08 rounded to the 7. Okay, next one here. For all positive values of x, looking at this expression, So first thing we could do is we can simplify this. The square root of 16x squared is 4x. We're going to multiply these together. So that's what I did over here. When we multiply, we add our exponents. So this is like a little imaginary 1 here. So we're going to add them up. So 3 over 3 plus 2/3 is going to give us 5/3. So it's 4x to the 5/3. And then what we're going to do is we're going to convert this. Before we do that, we're going to simplify it, which is over here. Cubed root of 8 is 2. Cubed root of x cubed is x. We're going to multiply that by the cubed root of x squared because that's what's left over. So this is going to be 2x times x to the 2/3. Do the same thing that we did on this side. So we have 2x to the 3 over 3 times x to the 2/3. Add them up. We get 5 over 3. Now we have like terms, so we can add the coefficients. And 5/3 is the same as the cubed root of x to the 5th. So it's going to be choice 2. Okay, next one. We want to have the equation of a parabola given the focus and the directric. So I did a little sketch that always helps me. I drew my directric at y is equal to 9. And my focus, my graph's a little bit off. I apologize for that. We'll have our focus here at -2, 5. Therefore, since our focus is below our directric, we know that our vertex needs to be in the middle of that. So our vertex is going to be at -2, 7, and our parabola is going to open up down. So we have our vertex at -2, 7, our p-value of 2, and we're going to plug into this equation here. Y minus k squared equals 4p times x minus h. So just plugging in our values, h, k, and p, and you should get choice 2. Y minus 7 squared equals -8 times x plus 2. And again, negative because it's opening down. All right. This one here, we're just going to go ahead and put in our calculator. So I already have it written. I already have it graphed, but I'll show you how to put it in your calculator. Okay, go to y equals, put in your values. Now it says only using this domain, so from -1 to 4. So if you graph it, you'll notice that it's going to keep going, right? Okay, so it kind of has this shape here, and it's going to keep going. But we only want to graph from -1. So we have -1, -10 to 4, 10. So notice how in my graph, there's no arrow, and I'm only graphing these points. Okay, so next one, we're going to algebraically solve for x. So we have a radical, so I'm going to isolate the radical. Okay. And then what we're going to do is, now that my radical is isolated here, we're going to square both sides. So squaring both sides, just get rid of that radical. So 6 minus 2x. We're going to use FOIL to get x squared plus 42x plus 441. We have an x squared, so I'm going to move everything over so that this side is 0. And then we're going to factor. Now, last but not least, we're going to want to substitute in our values to see if we have any extraneous roots. So I'm going to go ahead and substitute in -29. Okay, and when I do that, I end up getting -21 is equal to -37. So since they're not equal to each other, we cancel this out. And then if I was to substitute in 6 minus 2 times -15 plus -15 is equal to 2 times negative 15 plus 15 minus 9. And this is going to be negative 9 is equal to negative 9. So this checks out. Oh, sorry. So our answer is just negative 15. All right, last one. Carla wants to start a college fund for her daughter. So we're starting off with $63,000, and the rate is 2.55 per year compounded monthly. So what's the equation? So we're going to start with our principal amount. We could say, oh, not that. T is going to equal, actually, C of T is going to equal our principal amount times 1 plus our rate over 12. I should say over n, the number of times it's compounded, times nt. So we can see here, we're just substituting in our values. 12 because it's compounded monthly. There's 12 months in a year. We want to put our percent as a decimal. And then moving on right along, calculate algebraically for when it's going to reach 100,000. So C of T is going to equal 100,000. And we solve by dividing both sides by 6,300. And we get 1.58373. We're going to go ahead and simplify this here. Now that brings us down over here. Since we have a exponent that has a variable, we're going to log both sides. So I log both sides on this side. When I log both sides on this side, using the power rule, the exponent comes out in the front. Solving for t, so I'm going to divide by log on both sides. Last but not least, to isolate t, I'm going to divide by 12 on both sides. And then we're rounding to the hundredths of a year, so we get 18.14. Now remember, always round at the end. So you see how I have a lot of decimal values? You always want to round at the end, because if you round in the beginning, you might be a little bit off. Okay? All right, if you have any questions, please contact your teacher. Thank you.